So how does a high pressure system affect the weather?
Okay. You have, let me, best way to do that is to pull up a map and show you what goes on. Okay. So here you've got a high pressure system, here you have a low pressure system. Weather systems generally move from west to east because the air flows from west to east. But air also goes up and down. Okay? It goes horizontally, but it also goes vertically. So in a high pressure system you have sinking air. Air is going down underneath high pressure, and it's going up underneath low pressure. When air goes up, as in a low pressure system, it rises. So you have air coming from the fairly warm ground, rising into colder air, and that forms clouds and sometimes storms. This is the opposite. You've got air from above going down, and when it goes down, it warms up. So, and the whatever clouds there are disappear because you're taking you're going in the opposite direction. Instead of raising warm air, causing cooler air to sink. As the cooler air sinks, it warms up and clouds disappear, so under high pressure you'll have sunshine.
Okay.
Does that make sense?
Yeah, and with a low pressure system, it's opposite?
It's opposite. You've got rising air and clouds form and then you'll have storms. Now when air sinks in high pressure, okay, it's like if you took, let's say this is a bicycle pump, and you held the bottom of the bicycle pump, and you pumped, your hand would warm up down here because you're squeezing all the air into a smaller space. And with high pressure, it's the same thing. The air is sinking, so you're squeezing it against the earth, so it's compressing and warming up. But in the winter, you can have high pressure with sunshine and very cold weather as well, because the air is cold to begin with, and it just can't warm up that much. So it almost always means a clear sky, but it doesn't necessarily mean it's warm. It could be warm. It would be warm in the summer. It could be cold in the winter.
And what types of devices do you and other meteorologists use to predict the weather for up to a week ahead?
Okay. We use computer models as a starting point. Okay. There are about half a dozen computer models, or computers, supercomputers around the world that put out computer models. This is an example of a computer model. This one is put out by Environment Canada in Montreal. And what they do is they take weather information from all the observations made around the world, the airports mostly, and information from weather balloons, and all that data is fed into these supercomputers, and the supercomputers then try to figure out what's going to happen next with the weather, okay? And they put out these maps. And this one's one out. Oh, here. This one. So it's showing at 10:30 at night tonight. There'll be some rain over here, a few showers down here, Calgary's right there. And then we can move it forward. 9:30 tomorrow morning, got some showers coming into Calgary. And so on and so on. But there are many of these different computer models that come up with slightly different forecasts. So we have to go in and we have to find out which computer model we think is working the best, and then use that to base a forecast. So I'm going to find another example. No, I don't have one here. change things up a little bit just to show you how they can differ. But the way you figure out which one to use is you try to find out which one, you go to the current time and you try to find out which model is giving you the best depiction of the current weather. And then that's the one you choose to use as your base to forecast the weather. So I'll take this one. So this one I'm using the, actually I'll use the other one because I chose the rainfall. This one is using the Canadian model. If I went to, this is an American model, if I go to that, see it's just a little bit different. It shows more snow over here. The Canadian model showed all rain. So it's up to us to take a look at the various different models and try to see which one is making the most sense.
Do the seasons affect the pressure systems, and if so, how do they affect it?
Okay. We're in fall and spring are the seasons in which the weather is the most volatile. Okay, in the summer you've got fairly consistent weather. It's warm. It's in this part of the world it's usually sunny. We get some rain, but over time there's very little change. In the winter there's very little change. It's cold and miserable, right? Sometimes you get snow, but overall it's cold. But in the spring and fall it changes a lot because you're making the transition from the warm season to the cold season, and spring and fall are in between. So at that point things start to happen that make the weather a little bit more difficult to predict. And it does affect the high and low pressure systems in the upper atmosphere, which is what I'm going to show you here. Okay, this is a map. Stop. This is a map showing you the jet stream, okay? And what I'm going to do is take off the clouds because I'm kind of getting in the way of what I'm trying to tell you. And it'll show, there are a lot of, when there are dips in the jet stream like that, that's a trough caused by low pressure, okay? Trough caused by low pressure. This is the center of low pressure here. Okay, and you have a bump up in the jet stream that's caused by high pressure. High pressure is pushing warm air north. Low pressure is pulling cold air south. In the summer, for a lot of the time, you don't get this undulation. You don't get these movements. It's pretty much west to east. Okay, and the main separation between the cold air and the warm air is up here, right around the 60th parallel. So we're in the warm air mass. In the winter, the cold air comes down here. Right about there is a separation between the Arctic air and the warmer air to the south, and we're in the cold air mass. In the fall and spring, the cold air is fighting to get to the south in the fall. In the spring, the warm air is fighting to get to the north. They start pushing this thing and squeezing it around and making all these dips in the jet stream. So we've got colder air coming down over here. The warm air is not giving up here. It's not letting the cold air come in, but it's a battle in the spring and fall for the cold, in the fall for the cold air to take the place of the warm air, and in the spring for the warm air to push the cold air to the north. So it's in the spring and fall when the seasons affect the systems the most.
What devices are you looking at to predict the weather in the future, and how will this give us a better understanding of the weather?
Well, again, the main thing you look at to go ahead in the future is computer models. They are pretty accurate for 3 days. After 3 days, they really drop off in accuracy. And they're always working to improve them. A 3-day forecast is as accurate as a 1-day forecast was 20 years ago. A 5-day forecast is as accurate as a 3-day forecast was 10 years ago. And as they continue to improve these models, we'll see improved accuracy in forecasting. The old way of making weather forecasts, where you would sit down with a map as big as a table and draw everything on it based on readings from weather stations, that's all gone now. That was a good method for its day, but it's very time consuming, and with computers now you can get a lot more accuracy in a shorter time, and that's going to continue to grow and get better. Does that help?
Yes.
Okay.
Thank you.
Okay.